Hi, my name is Kyle Mayhew, and I work for Cyient as head of our strategy, marketing, and business development group for our geospatial practice. Today, I'm going to talk to you about one of the solutions we have for communication services providers. It's called 5GIP. So today, we're going to give you just a brief background on Science Geospatial Group. We're going to talk about a particular business challenge, and then we're going to go into what is 5GIP, how does it work, the business benefits, and then I will show you some screenshots from our platform. So being part of the geospatial group at Science, we obviously love our high resolution imagery and maps. And our focus is around accelerating growth by leveraging the power of geospatial across our different industries that we serve and utilizing our cross industry expertise. And when I say the power of geospatial, what I'm talking about is the power of location. So, our underlying goal is how do we deliver decision support solutions underpinned by geospatial to help our customers solve business problems that matter? So, as part of the geospatial group, one of the areas that we're focused around is helping our clients achieve their digital transformation strategies. And one of the ways that we've been very effective in doing that is by focusing on their goal of accelerating planning, design, and asset maintenance. So, this includes a number of areas, but some of the things that we do are integrating different types of geospatial technologies across business processes. This could be, customizing different offerings or different data solutions for niche market needs. And again, leveraging that power of location and other types of geospatial data and layering that on top of our clients' data and allowing that to give them deeper insights. Automation is a big part of what we do, and a lot of our transformation initiatives have quite a high degree of automation built into it. It really delivers that scale and the throughput and really the value for money that our customers are looking for. Another area that we're focused on is the ability to contextualize different types of geospatial data to deliver business intelligence and value for different types of users. So we work in the planning and design. We work with the operations and maintenance. We work with strategy teams. We work with customers on how they acquire new clients. So a number of different users who have different requirements, and we're able to again work with the data to make it speak the right language for them. We do quite a bit of software development and integration with all the major enterprise GIS systems, so Esri, GE Small World, and others. In addition, we use a lot of technologies around artificial intelligence, machine learning, and Cyient has quite a bit of unique IP built up that we implement to provide these types of customized capabilities and solutions. And as I mentioned before, the ability to deliver the power of location and insights to our clients, not only within their applications, but also the business processes. So one area which we'll touch on briefly, although it's not necessarily included, it's not the core focus of the 5GI platform, is around asset maintenance. And I should probably preface this: 5GIP is one component of a larger life cycle of offerings that we work with communications companies and in fact utility companies on around just accelerating that whole plan, design, maintain, and eventually dispose of the correct assets at the right time. So, to maybe put it in just a slightly different view, one way that we describe what Science Geospatial Division does is we help manage the capture, manage, and exploit continuum around data, and especially geospatial data. So there's different data sets that exist out there. Scient has the ability to acquire the data, using our own internal resources, but also through a global network of partners. Once that data is captured, we process, manage that data, get it into the right formats so that it's usable. And then the real value, frankly, comes from how we exploit that data, how we make the data tell a story and utilize it to bring different insight or solve a business problem. So let's talk about some of the challenges that face communications companies as they look at deploying and maintaining 5G in small cells. So the business challenge that we originally posed through one of our customers, this was over 2 years ago, specifically around how do I scale up my ability to deploy 5G? And so one of the challenges they said is we have our process today, but the ability to locate poles and locate them accurately and quickly is a bottleneck. So that was kind of the premise of how we started this whole route to eventually come up with our 5GIP solution. So we know that communication service providers or CSPs use pole location data for their initial planning and RF simulation processes before they go out and do further investigation and ultimately deployment. And so the practice today is that a lot of companies use field site survey crews to go and gather that data in small blocks, which is fine, but it lacks scale and it is time intensive. It can be expensive. And when you're scrambling to be the first in a market or improve your offering, your existing services in a given market, scale is important. So we took this potential problem and we looked at it further. What we were finding is data is available on different pole locations. And when I say pole, I mean in the traditional sense, a wooden or a concrete or some type of composite pole that has utility and telecom assets on it. But, you know, poles can mean a number of things. Sometimes our customers call them nodes. We've heard a number of terms there, but I'll just use the term pole. So some poll data exists. A lot of companies have their own poll data. They have data that they can purchase from utility companies. People have gone onto Google Maps and Google Street View and tried to identify polls, which again, it's one way to do it. However, the accuracy is quite poor to put it bluntly. And so we've seen a number of clients that have challenges with that. So all around, we need to find poles. We need to find the exact location of those poles, and we don't know if our data is good or not. And ultimately, we want to be able to scale this process. So that was the problem at hand, and that's where we started to apply geospatial types of services and solutions to come up with an option for how to address this. So let's talk about 5GIP. This is a platform that Cyient developed in-house, and this particular platform is cloud-based, and it uses multiple types of imagery data sources and machine learning to essentially identify the location, the latitude and the longitude, and the pole type. So what it does is, or how it works is we work within a defined area of interest, and Science, again, has access to a number of different data sources. So we locate the proper imagery needed to be able to identify with the right level of accuracy. We are able to deliver that information rather rapidly. It goes through a process which I'll run through in just a moment. Again, using machine learning to automate a lot of those steps. And then the end result is that we have the locations within a given AOI, and the accuracy is what's important. So the accuracy that we're delivering is sub 1 meter. And again, it depends on the imagery source and the resolution of that. But in certain cases, we've been able to achieve 30 to 50 centimeter accuracy. So again, scale is important, and that was one of the design elements of our focus on addressing this business challenge. And that's where we are able to bring a high level of automation and machine learning to the process and effectively be able to deliver polls within an entire city in a matter of weeks. So this data is provided to our customers typically as a shapefile so that they have the raw data so that they can export into their systems, but we also deliver it in our 5GIP platform for viewing and making modifications and other enhancements. And then finally, I touched on this before, but 5GIP actually sits in a larger offering within Cyient. We use the term virtual walkout internally, and essentially what that is we are trying to bring more of those elements of planning and design capabilities to the desktop level. Again, there's definitely a need for the precision and the accuracy and all the things that come with a field site survey, but we want to do more of that work upfront virtually so that we're being very effective and efficient with how we utilize that manpower and the equipment and really the time to deliver on our business requirements. So how does 5GIP work? So as I mentioned, there's a number of different imagery sources, and that imagery can consist of satellites, aerial, we use drones sometimes. We have vehicles that capture ground-based or mobile mapping. And sometimes for the right scenario and solution, we actually use field resources. We deploy ground crews ourselves. So all that data, irrespective of the type or the format or to a degree the resolution, we're able to analyze that based on the business need, bring that into our feature extraction engine, which is run from Science proprietary AI systems. We are then able to pull out the different polls. And again, a poll can be any type of asset that our customer is looking for. But in this case, we were looking for the traditional telephone poles, if you will. So once that's done, that goes into a staging area, and all this automation is really what drives the throughput. We use a human in the loop validation process. So the AI extracts the data, what it thinks is a pole, and labels as a pole. And then we have engineers, photogrammetrists that review that information, confirm the accuracy, confirm the pole type, make any modifications, and then validate it to be complete. So once that's done, we then take another visual process where we look at how the poles sit in reference with, say, a street or an urban development, and we make sure that we've got the right linear movements and we haven't missed anything essentially. Sometimes there's some georeferencing if we have other data sets that we want to layer on top, and that goes into our reporting engine, which ultimately delivers the results out. And so again, this process from start to finish is highly automated and quite seamless and has the ability to push a lot of data initially in and therefore a lot of pole location out. Once the data is loaded into 5G IP, then there's the option to do more types of, I'd say, advanced analysis. So around probability of different types of assets, we can do clustering, we can do correlation of distance, and a number of other things. So just to kind of show you where all of this fits in terms of imagery and the sources. So Science been doing this particular type of work for a long time. The 5G IP platform's been up and running for a couple of years now. And what we found, obviously, is that distance matters. So there's a number of satellite providers out there that we have partnerships with. Their best resolution in the best case is 30 centimeters. They're on average, I'd say 1 to 3, and in some cases 5 meters. So with satellites, obviously, imagery is a bit. It's definitely prevalent. It is inexpensive compared to other sources. It's widely available. There's some companies that have constellations, so you can get pictures daily, weekly. The currency is very good. However, the resolution presents a challenge, and the horizontal accuracy and precision are also challenges. Fixed wing or aerial, so again, much better resolution quality. And what we've found is that aerial is a great in-source put or input for our 5G IP platform. And the 7.5 centimeter resolution is really just excellent for what we do and how our machine algorithms work. And this is kind of one of the, I'd say, the primary data sources. And then you can read through the rest. So there's definitely pros and cons to each. You're typically trading off resolution, which again gives you the granularity, and to look at it from our photogrammetrist standpoint, the individual pixels that then again translate into how we identify the pole and place that lat long correctly. And then you're also trading off time, expense, and the ability to transmit data from start to finish through the process. So obviously, the closer you get to your end object, your asset, the better the imagery and the resolution, but you're going to have some trade-offs. And so Cyient has been through all this, and again, that whole capture, manage, exploit. We manage this entire continuum of the acquisition to be able to deliver this service to our customers. So really looking at the benefits, what 5G IP does is it reduces the cost as well as the time of the high level planning process. And we're doing this by identifying assets quickly and at scale and in a much more cost effective manner than some of the traditional methods that are being used today. We're making this data available via a cloud platform. So whether you're at work in your office behind the computer, if you're out in the field on a tablet, if you're like most of us and working remote in this current pandemic environment, you've got access to this information. I've talked about scale a number of times, but it's just really important to highlight this. The technology that we've built in behind this, plus the the human powered geospatial expertise, is really what drives the value, and certainly drives the ability to ramp up. We have a predictable pricing model. There is a secondary spatial analysis tool set that we provide and are working with customers on. And again, this is pretty customizable. So some clients simply want the pole location, and that's great. It's a very proven model and it's quick. Others want us to do a little bit more data analysis and insight. And others still yet want to take their information and overlay it on top of ours, whether that's in the 5GIP platform or in their enterprise GIS systems. And that kind of touches on the last point, the integrated data layers and the deliverables. So with that, I do want to just kind of cover a few areas. So questions that we get quite often when we show 5GIP. What are the different data inputs that you use for your platform? So again, I covered those. We have the ability to use satellites, aerial, um, mobile mapping, which again is more from the ground looking out and up, so from a moving vehicle. And there's definitely some pros and cons to the different ones that we've described. And we're primarily using high resolution imagery. We also have the ability to marry different types of data, including LiDAR data. That kind of gets to the bigger picture where science has a larger focus around how we work with communications and utility companies. But it's certainly something that we capture, something that we process, and we have the ability to integrate into 5GIP. And not to touch too much on LiDAR, but what that allows you to do is measure and measure accurately. So the questions, some other questions is how accurate is our solution? We are definitely able to deliver sub-meter accuracy, and like I mentioned, it depends on the data set that we use and kind of the customer's primary requirements. Some clients tell us that 2 to 3 meters accurate is fine. I'm more focused on costs and available recency of data. So in that case, satellite imagery might be a good fit. If customers say, I need 50 centimeter accuracy, then we have the ability to deliver that. We just have to use the right data inputs. So some other questions are, can you see attachments or loading on the pole? We have the ability to capture that. It is not in the basic offering that we deliver through 5GIP, but certainly part of the broader offerings that Cyient has. So that is not native in the basic version or the kind of the regular version of 5GIP. Some of our customers say that they have some poll data and they're not sure if it's accurate. So we have a way to be able to ingest your data, run our algorithms on accurate imagery, do a comparison, and help you update or modify or append your data to be more current and more accurate. And then another question we get is, how is our solution priced? We have a number of pricing models. One of the most popular ones is to price it by pole located. And I would just encourage that if you're more interested in pricing, then we just have a separate discussion around that. So with that, some of the different imagery that we have visible, like I mentioned, LiDAR, 2D maps, we have ortho imagery and 3D maps as well. So now I'm going to take you into just a few screenshots of the platform, and we can get into a more active demo when we speak in person. So here is our login to 5GIP. So once the user logs in, it takes you to the main page. In this case, I have selected Canada as my viewing area. So we're going to zoom in here. And what you can see is a number of navigation features. So we have the different layers that we have to turn on for our deliverables. And in this case, the production layers are different types of polls. So we have a general classification, and of course, this can all be customized based on the customer's needs. We had a client in the U.S. that was looking to do some small cell rectification and kind of modernization. And one area that they wanted to look at was, could they use water towers? So we were able to load that, train our machine learning algorithms to identify water towers, and that became a layer. But so traditionally, what we find are utility poles, lamp posts, traffic lights, and the larger communication towers or transmission towers. So from here, we do have a zoomed in area. In this case, it's Winnipeg. Like I mentioned, we're focused on Canada. So we've got our established area of interest, and this is where the 5GIP platform is designed to go and look for poles. And once you zoom into a specific spots, I chose this particular area because it's by the river and has a nice, what looks to be a baseball park by it. Then you can turn on the different base map galleries. So, these are neat, I'll say, but again, depending on what your requirements are, imagery and 2D maps seem to be the most prevalent ones that are being used. We also have a dashboard built in, and again, this is customizable based on the specific requirements that we're working on. In this case, we're seeing polls. We have the ability, again, through a more expansive offering to capture pole height, capture buildings in a particular area so that you can draw on the map and say, how many poles are here, how many buildings are close to those poles. I'd like to know buildings that are within, say, 10 meters of any poles. So again, this is just a dashboard that's pulling all of that data together. We can, again, using some more enhanced services, look at occupancy and show some ratios and some information there as well. So here we have our 2D map. We've overlaid this with our orthomosaic, again, turning on the production layers. And when you zoom in, this is where you begin to see the pole location. So we have all the layers turned on at the moment. And as you can see on the map here to the right, we've got some yellow spots. So these are utility poles. The light blue are lamp posts. I see some red over here. Looks like two baseball parks. Some more red over here. So these are traffic lights. And you have the ability to turn on and turn off different layers to be able to see specifics. And then the further you zoom in, you get a little bit more granularity of detail so you can see where this information is located. And when you click on a particular icon, it brings up this field. And so we have attribute data and metadata. So what we're looking at is a neighborhood very near that baseball park. We've clicked on a pole. This is a lamp post. You've got the lat long of the location of the pole. This pole was found by Cyient on Saturday, February 8th, 2020. The evidence date is the date of the imagery. So I mentioned this particular imagery for this Winnipeg AOI is using 7.5 centimeter aerial imagery, and it was captured on June 2019. And this is just the Cyient user that identified this pole, so we can always go back and trace history and information. Now, the other area that I'll cover is just quickly this attribute data. So over here, this is where Cyient, our clients, whoever is interacting with their login can start to add information. So for example, we've delivered this to our customer. Our customer initial planning says this neighborhood is a good candidate for some of our services. We're very interested in this particular street corner for different reasons. Maybe there is an access point nearby, but we're concerned about, the hard surface here or the accessibility for our field crews to do some digging. And so those notes can be added here, and this can be viewed by anyone who has access to the internet that has the login, so anyone within that client's team. And then, for example, the field crew can read those notes, write comments. All the data is bisynchronous, so everyone is kind of kept up to date. And this just helps further accelerate the exchange of information and how our customers plan. So again, this was just a glimpse of the platform. I look forward to speaking with everyone, live and having a Q&A and really understanding what types of business challenges you're faced with and how geospatial and geospatial data might be able to help solve a problem. So thank you very much and have a great day.